For being good at math, right? Oh, my favorite student? Yeah, you'd think. All right. Examine this graph. Did I say graph? What kind of a graph is this? This is a distance versus time graph. You know what? I need to pause because I forgot to give people who were away. Let's continue on. I would say, what kind of a graph is this? This is a distance versus time graph. Height means how far. Slope means how fast. As opposed to if it was a velocity versus time graph, height means how fast, slope means acceleration. All right. How far is the truck from its starting point? You know what? How far is the height? So after 10 seconds, how high am I? I think 300 meters, yes? After 15 seconds, I'm still 300 meters, from which I infer that I'm at rest. After 30 seconds, I am 200 meters away. I must have gone backwards a little bit. After 45 seconds would be right there, halfway between 800 and 600, I think I would be 700 meters away. If I make a mistake, give me a holler, because my brain is not what it once was. After 50 seconds, that's the end of the path, 800 meters away. 1 mark for each of those, please. I would take a half mark off if you forgot units. I will be fussy with that for the rest of the year. You'll all develop the habit whenever you write a number down, you'll go, oh, check the units whenever it's a final answer. Got the quiz? Doing good? Got your binder? Got your stuff out? Where's your stuff? Is it in your locker? It's at home? So you're going to have to mark it this weekend, email me your score, and you're going to be having to be the butt of my jokes for the rest of this class. In fact, I'm going to... Oh, you're lucky this sword is attached to the belt. For those of you listening on YouTube, it's Halloween. I'm dressed as a pirate. I didn't actually threaten a kid with a sword. Things I just thought of because I am posting this online, you know, warts and all. Now, Priya, it says truck's velocity. No. This is a distance versus time graph. Slope. So between A and E, I'm going to go rise over run for that chunk right there. The rise is 300. The run is 10. I'm doing this in my head. Is it 30? Yes? Now it gets a little trickier. When I start at 0, rise over run is easy because you're starting at 0, 0. I can do the math in my head. B, oh, you know what? B is actually really easy as well. What's the velocity on that section right there? So I can do that much in my head. B, I said 0 meters per second. Again, if you forgot the units, half mark off. C, first thing I'm going to do, because you know I'm the king of being dumb, I wrote the negative there right away just to remind myself it is slowing down. It starts out 300 high. It ends up 200 high. The rise is 100, technically negative 100, but Ethan, I put the negative there already. Thankfully, the run, again, is 10 seconds. I can do this in my head. Is negative 10 meters per second? D, positive, and looks like fairly fast. 600, 200, it's going to be 400 over, and I think it's also 10 seconds long again. So I think D is 40 meters per second. And E, 600 to 800, I think it's going to be 200 divided by 10, 20 meters per second. Yes? Looks like this first left side of the page is out of 10. You can give yourself a little score if you want, or you don't have to. Circle the correct letters. So 1 mark, all or nothing. Section, oh, what kind of a graph is this? This is a distance versus time graph. Slope means how fast, height means how far. A is speeding up, slowing down, or constant speed. What'd you say? Speeding up, slowing down, or constant speed? Jay? Constant speed. What would speeding up look like? I'm going to say the same thing. By the way, if you haven't picked up on this, I suck at these graphs. If you've ever come to me for help on a graph, you may have noticed, Adrian, I actually talk it out to myself. So if I was doing this, I would say speeding up. What does that look like? Speeding up, going faster, increasing slope, getting steeper. This is what speeding up would look like. But I can't just glance at these. Maybe you guys can. I'm not a good visual grapher learner. I can't just glance at these and see the answer. I have to talk my way through it. So if you're finding this tough, you're normal. A is moving faster. Sorry, A is moving forward or backward? Help me out. What would backward look like? That way, okay. On a distance versus time graph. B is moving faster than or slower than? Okay. True or false? Oh, what kind of a graph is this? Distance versus time graph. True or false? This object is at rest on interval C. False? Oh, because its distance is increasing. It's getting further, so it can't be at rest. Also, there's a positive slope. That means there's a positive velocity. It's going forwards. False. Where is it at rest? I think D, because its distance isn't changing. Now, before I go to the next one, what if this, don't write this down, what if it's been a velocity versus time graph? Where is it at rest? Right there, and that's because height is your speed. It starts out at rest, but it's never at rest again. It speeds up, constant speed, if this was a velocity versus time graph. That's about, those are good questions in terms of velocity time graphs that I might ask you to interpret on a test. When is the object at rest? What kind of a graph is this? Distance versus time? G. When is it going the fastest? What's steeper, F or H? I think F, yes? By the way, again, what if this is a velocity time graph? When is it at rest? Right at 0. When is it fastest? When it gets to the highest, because the height is the speed. But it's not a velocity time graph. I think the front page is out of 17 grand total. If you want to, you can put a total of 17. You don't have to, but if you're, you know, a good marker, you can. Ooh, curves. Okay. What does 4A want me to find? For the whole trip? Then I tend to abandon the graph, and I just use this. Average speed is distance over time, and I say the total distance is 25, and the total time is 22. But for what it's worth, Michael, it still is the slope of that line, because if I did go rise over run, I would end up going 25 over 22. It's just I find it quicker to just go distance over time. It's going to be... 22 is a yucky number to divide by because there's an 11 hidden in there. 1 point. Now, how many sig figs? If you said 1.1 and then you did 3/6 repeating, that's fine. If you said 1.14, that's fine. If you said 1.1, that's fine. In fact, Renzo, you could make an argument that because on the graph these numbers are only to 1 sig fig, that really I should only go to 1 sig fig. So I would say, Tori, technically, if you said 1, I'd say, boy, that's inaccurate, but I'd live with it because under sig figs, it's technically right. But I've told you I'm going to ignore sig figs. When in doubt, I go to 2 or 3. Which one, Mr. Duick? Honestly, it depends on the decimal. Here, I'm going to go to 3 because I think 1.14 is more accurate than 1.1. But I don't like being much more accurate than that because this is garbage data anyways. So I'm going to go 1.14, and I would, is it meters per second? Yeah, I would take a half mark off if you forgot the units. Now, to find the average speed for each of the following intervals, it's going to be the slope of the line connecting those 2 points. So to find the average speed from 0 to 2 seconds, it's the slope of that line. That one's a nice one because the rise, I'm pretty sure, is 5. The run, I'm pretty sure, is 2. I'm pretty sure it's 5 over 2. This one I can do in my head. It's 2.5 meters per second. What about from 4 to 8? Oh, you know what? That's a pretty nice one as well, because I can just eyeball that. Adam, what's the slope of that little chunk right there? Fancy word? At. Yeah, okay. Where it's going to get a bit trickier is in the next couple. Okay, 14 to 18. It's going to be the slope of this line. What's the rise? Well, definitely I'm pretty sure I'm 20 high. Here, well, what do you think? Around halfway between 10 and 15, what would be a good height to use? 12.5. Now, Connor, if you used 12, I'd give you full marks. In fact, if you used 11, I'd give you full marks. I'd probably say, I don't know, but I'd give you full marks. If you use 13, I'm fine. 14, I'm fine. If you use 9, 9! Huh? Get that? 9? Huh? Eh? Huh? No. And if you used something above 50, no. I'd really take anything between 10 and 15, but I think it's close to the middle. I would go with 12.5. So my rise is going to be 20, take away 12.5. My run, that I can get pretty easily from 14 to 18 seconds is my run. Yeah, I see Hayden going, or he's golfing. I've seen him golf. 4, no, leave me alone, Mr. Duke. 20 minus, so it's going to be, take away 20 take away 12.5, all divided by 4. 4, oh, sorry. 2 numbers on the top. I'll go 1.9, yes, 1.88, yes, 1.875. I think 1.9 is pretty good. Okay. Did anybody use something different besides 12.5? Would you use? I'd take it. So you would have had, I'm going to guess, doing it roughly in my head, about 1.8 or 1.7 as your slope?
I got 1.75.
Yep, I'll take it. Okay. The graphs are great visually. They're lousy to read decimals from, and that's where they break down. You can only get nice exact answers if you happen to go through a grid line. Well, most of the graph doesn't go through a grid line. It limits the questions I can ask. So as of today, aside from your test, we're going to be leaving graphs pretty much behind. What did I say, 1.9? Meters per second. 6 to 17, okay. I'm going to erase all this just because it clutters up my graph. 6 to 17. 17. You know what? I bet you it's that point there. How high? 15. How high? 5. What's the rise? 10. And I can get the run exactly from 6 to 17 seconds, I'm pretty sure is 11 seconds. 11's a yucky number to do math with. I know it's repeating, but I haven't memorized. Like, I know when you divide by 3, it's 0.33 or 0.66. 11, it's, I can't remember. How about, I'll go 0.91. Yes, I'd take 0.9. Yes, I'd take 0.90 repeating. I'm going to go 0.91 meters per second. Where I'll take a lot of leeway is the instantaneous velocity. And deliberately, I gave you yucky numbers. How do I find the instantaneous velocity of a curve? Ty, this is when I'm going to lay down my ruler and kind of eyeball it. So the first thing I'm going to do, actually the first thing I'm going to do is clear my graph off. Ty, instantaneous velocity, what was the first time they gave me in part A? How many seconds? Just read, how many seconds? Yeah, C part, sorry, I said part, C part 1? 12. So Ty, first thing I would do, if you're not doing that, put a point there. I'd photocopy these so you can write on them. And I think the steepness is about kind of, maybe like that-ish, kind of. Maybe a bit shallower, maybe a bit steeper. Oh, I fluked out. I went through one nice point right. Actually, you know what? I would argue I went through right there. I didn't go through any other nice points. So I'm going to have to eyeball this. I'll use that point there, which looks a little further than 9 seconds. I'm going to totally guess off the top of my head, Mateo, like 9.2-ish seconds. I can tell you exactly how high it is, though. 0 high, which is why I picked that point. I knew I could at least get one thing exact, and I'd rather do math with zeros. Okay? So my rise is going to be, how high is this point here? 25? It's going to be 25 minus 0 over, my run is the yucky part, 16 seconds. Minus, yeah, if you guys can see, I don't know if you can see in the back, I'm definitely slightly closer to the 10. So I'm a little bit past 9. I'm going to go 9.3-ish. I don't know. 25 divided by 16 minus 9.3. 3.7? I'd probably take anything between 2 point something and 4 or 5 point something. In fact, let me look and see, because I did this last class. What did I get as my answer in block B on this quiz here? 3.3. So there's already a big difference. I got 3.7. Is that what I said? Yeah, okay. I'd take it. Show me your quiz later, and I'll look at your points, but probably what I'm going to say when I'm done is lawyer with me, and this is one you can lawyer with me an awful lot. Okay. By the way, the reason this is also so tough is, am I going up by ones along the x-axis? No. Am I going up by ones along the y-axis? No. That means any slight tilt is hugely multiplied. You're going to get a way different answer. If I wanted our answers to be really close, Tori, I'd give you a graph going up by ones and by ones, and I probably will do that on the test just so our answers are roughly close. But I wanted to give you one that was a little out there. The second time, 16. I'm going to erase all this because I can. And let's go full screen. Jay, you going to make it? I don't know. You looking tired. You awake? Okay. Because otherwise, you know, we'll release the cannons. Release the Kraken. Oh, that's a good pirate saying. I can do that. What would that be in my class? I don't know. How many seconds was it? 16? Yeah? Right there. First of all, definitely slower than at 12. I should get an answer less than my previous one. I should get an answer, for me, below 3.3. That gives you a bit of a breathing room. 16 seconds. Yeesh. Maybe? Ish? Kinda? Sorta? Hey, I go right through there. Hey, look at that. I go right through there. That's a wonderful fluke. And again, if I hadn't gone through a nice point, Priya, I'd eyeball it. This is why I'll take a wide range. Looks like my rise is exactly 5. Yay! And my run is 22.8. So 5 divided by bracket 22 minus 8. By the way, I could go 22 minus 8 in my head, and if I was doing homework, I would. Is this a quiz? I'll use my calculator to avoid making dumb mistakes. I'm fine with that. I got 0.36. I'd probably take anything between about 0.2 and 0.5. Just for curiosity, what did I get in my Block B class? 0.42, that's close to 0.36. So give yourself a score, please, at the top of the page out of 24. And now is the time to come lawyer with me. I'll pause the video. Relative velocity. Or, hey, what happens when you have two objects moving at different speeds and you don't feel like graphing them because... What happens when graphing breaks down? By the way, I should say you can actually solve all of these with graphs. It's two graphs. It's finding where they cross. Remember in Math 10 when you learned how to solve systems of equations using the addition-subtraction method or the elimination method where you had the x's and you had an x to cancel? You can. We're going to do them in 2 lines, not in graph and a bunch of work. How will you recognize that this is a relative velocity question on the test? Because I do like these questions. You'll notice, Ty, there's 2 objects moving at different speeds, and he didn't give me a graph. Fair enough. Let me give you an example. You're driving down the freeway with your speedometer reading 100 kilometers per hour. When a white Escort hurtles by you with its speedometer reading 140 kilometers per hour. And suppose there's a tow truck parked at rest. You know what? We should probably underline the word at rest. That's important. Beside the freeway. What would the tow truck see? Or if I wanted to ask this in terms of physics, put your phone away. Were you looking at your... No, you're getting a wrapper out. My bad. Sorry. What would the velocity of u relative to the tow truck be? Well, the tow truck is at rest. So as far as the tow truck is concerned, it sees you traveling how fast? 100 kilometers an hour. What direction? Well, if you were in its rear view mirror, you'd be getting closer. If you were in front of it, you'd be receding away. We'll call that forwards. Now, I wrote here VU relative. You know what? I don't want to write this. Too much writing. Over here in the margin, let's say this. Let's let Y be an abbreviation for U. What would be a good abbreviation to use for tow truck? How about a T? What would be a good abbreviation to use for the Escort? E. Honda. Okay. So if I wanted to write this much shorter, I would write V, And you'll notice I'm putting vector signs on because direction is going to matter now, of u relative to the truck. Y with an arrow pointing to the t. I would read that as the velocity of u relative to the truck. You'll also see some people will put a comma instead of an arrow, or some people will just put the letters side by side. They'll write v, y, t. I don't like that because when I see two letters side by side, I always think times. So, arrow. How fast would the tow truck see you traveling? 100. What direction? So I'm going to write, I'll put the plus sign in just to let myself know that I did take into account direction. What's the velocity of the escort relative to the tow truck? What is the velocity of the escort relative to the truck? Direction. Forwards. Gonna make it, Jay? That was a long blink. Wake up. Here's where it gets more interesting, because that's not that profound. It's the speedometer readings. What would you see? Relative to you, how fast does the escort seem to be moving? 40. Forwards or backwards? Well, if it was in your rear view mirror, you would see it gaining on you. If it was in front of you, you would see its taillights receding. We would say the V of the escort relative to you is going to be positive 40 kilometers per hour. Why? Because mathematically, you're pretending that you're at rest and the world revolves around you, which many of you think anyways. I'm not going to write out the explanation, but does that make sense? What would the tow truck look like to you? Well, if you were driving towards it, you would see its taillights coming towards you. Or if you were driving past it, in the rear view mirror, you would see it receding off in the distance. What direction would that suggest to you, relative to you? Backwards. How fast? How could I show backwards? Okay. The velocity of the truck relative to you, as far as you're concerned, negative 100 kilometers per hour. Wait a minute, Mr. Dewick. In part A, you said I was traveling 100 and the escort was traveling 140. Now you're saying that the escort's traveling 40. What's correct? This is what Einstein asked. There's a reason why his theories are called the theories of relativity. And he said both of them are correct. Actually, what he said was there is no way to prove that any one of those is correct. He said that you can do an experiment in max if you're moving at a constant speed of 100 kilometers per hour and you do an experiment, you'll get the same results as the tow truck that is at rest. Okay? And you'll get the same results as the escort that's going at a constant speed of 140 kilometers per hour. If you were in an enclosed room with no windows, you could not tell that you were moving at a constant speed. There's no, but there's no way to tell. By the way, you guys are all dumb enough to think that you're at rest right now, are you? Is the Earth at rest? It's spinning. It's also moving around the sun. Is the sun at rest? No, the sun is moving through the Milky Way galaxy. Is the Milky Way galaxy at rest? No, the Milky galaxies are all moving around. You know what? Relative to the Earth, you guys are at rest, and we can do our physics and get the right answers. The same as someone who is going at a constant speed at 100 kilometers an hour in an enclosed room could also do the same experiments and get the same answers. This is why his theories are called relativity. It came out of him asking, what does it mean, relative velocity? Hey, what would the escort see? Well, what would you look like to the escort? How fast would you be traveling relative to the escort? What would V of u relative to the escort be? Negative? Why negative? Because if he was behind you, he would see your tail lights coming closer to him as though you were driving backwards. Or if he was in front of you, he would see your front headlights receding off into the distance. And if he pretends he's standing still, that means you're in reverse. Is that okay? You got to use your imagination. Okay. By the way, you notice I'm being way more careful with the vector notation now. I'm putting the vectors on the V's to remind myself, here, Priya, directions matters a lot. Okay. What about the velocity of the tow truck relative to the escort? Negative. Why? Oh, okay, 140. Sorry. Yeah, 140, but negative. It would be either receding once the tow truck passed it off into the distance, or it would be coming backwards towards it because the taillights would be getting closer. Is that okay, Max? Okay. Which one's right? Yes. They all are. I wrote down here, Mr. Dewick, is there a short way to write this? Yep, let's rewrite above. I was going to actually walk you through writing it out as sentences every time, and I decided, forget that. I'll show you the shortcut with the notation and letters and arrows right away. Okay. You do not perceive the escort to be moving away at 140 kilometers per hour. Ty, instead, to you, you see it moving 40 kilometers per hour past you because your frame of reference is your car. The relative velocity of any moving object depends on your point of view. We're good, Mateo? You can put it away. Or Kayla, you guys are looking at something. Can you put whatever that is away? Thank you. Your frame of reference. Sure, you see the car moving away at 40, but the car sees you moving backwards. In fact, you could even say negative 40, and I could scribble out backwards. How many of you ever walked on a moving walkway in an airport? Okay, you've experienced the same thing, especially if there's pedestrians that aren't using the walkway. Relative to them, you're walking really fast. Relative to the walkway, no, you're going walking speed. How many of you ever turned around and gone against the walkway? You can match the walkway speed so that your relative speed to the ground is 0, even though relative to the walkway, you're going negative walkway speed. Or you can even go faster and try making headway against it. Example 1, what's the relative velocity of the train passenger relative to the guy on the ground in each case? What does the guy on the ground see this passenger moving at? What is, how about we'll call it VREL, and we'll put a vector sign because direction is going to make a difference here. 16.2. Positive or negative? That'll be to the right. I'm going to put a plus sign. Normally I don't, but since direction is important for this lesson, I'll just reinforce it. What about here? Okay. So if they're in the same direction, we add them. If they're in opposite directions, bigger minus smaller, and the direction is in the bigger. Is that okay? Kind of makes intuitive sense. So here's our first thought experiment. What if instead of running at 1.2 meters per second, he was throwing a baseball, and the baseball went that way at 15 meters per second? What would it look like to the person who was on the ground? Put your pencils down, look up. Let's go primeval. Mother Nature, predator and prey, cheetahs and zebras. A cheetah is running away at 50 kilometers per hour from a cheetah that's going at 90 kilometers per hour. What velocity does the zebra see the cheetah having, and vice versa? So what's the velocity of the cheetah relative to the zebra? I think C and Z will be good abbreviations, yes? If the zebra had a rear view mirror, would it see the cheetah gaining on him or going backwards from him? Gaining. So is that forward or backward? We're going to call that forward. Sorry, how fast? Plus 40. 40. What does the cheetah see the velocity of the zebra relative to the cheetah. Well, what the cheetah sees is the hindquarters of the zebra slowly coming towards it. Backwards. Yes? How fast? Yeah, -40. Let's add an element of survival here. If the zebra starts out 90 minutes ahead, how long until the cheetah gets lunch? What's this question asking me to find? What's that 90? Right? Meters? Oh. I'm going to use the relative velocity, and because I know I want time to be positive, instead of using the vector, you can scribble it, I'm going to use the relative speed. 40, whether it's plus or minus, I don't care. 40 what? Units. Ooh, what units is the distance in? I need to do a conversion, so I'm going to go 40 kilometers per hour. I recall that to go from kilometers per hour to meters per second, it had something to do with the 3.6. Was it times or divide? Well, 100 kilometers an hour times 3.6 is 306. No, it's divide. If you're wondering, that's how I figure it out every time. In meters per second, the relative speed is 11.111. I'll write 11.1. I'm looking for an equation that has d and v and t. I think it's this one. Except, what do I want to get by itself? How would I get the t by itself? What letter is next to the letter t? A v? What's the v doing to the t? Adding, subtracting, multiplying, or dividing? So how will I move the v over? What's the opposite of timesing by v? Sage, if I hear you correctly, and I think I do, you're telling me that time equals d over... I mean, you can memorize all these if you want, but I'm telling you, we can derive them from our formula sheet from just one equation. It's going to be 90 divided by... I'm going to write 11.1, but I'm going to go 90 divided by... Haha, answer button, because that's 11, I'll use my more accurate value. Ooh, and that one works out nice. 8.1 seconds even. Hashtag nerd trivia, not in the notes here, but it turns out when cheetahs run full speed, they can run around 30 seconds before their body will overheat and they have to stop. And it turns out that zebras are born with an instinctive ability to do this relative velocity calculation. If you watch zebra herds, they will be standing about 32 seconds away at top relative speed, or 33 seconds away. And the ones that can't do the math, that stand 26 seconds away or 25 seconds away, get, well, weeded out. Those are the ones the cheetah gets. And gradually, evolution has built into the zebras the ability to instinctively do this calculation pretty accurately. You'll watch their body language change. They're totally relaxed at like 38 seconds top speed away. Not concerned at all, because they know, and the cheetah is smart enough to know as well, not even worth trying. Because if I try and I don't get them, I've wasted energy and I didn't get food. Do that 3 or 4 times, you're going to starve to death. So over time, dumb cheetahs also get weeded out, cheetahs that can't do the physics as well. And you thought it was only humans that did physics. Put your pencils down, look up. Example 3, turn the page. State the relative speed in each case. I didn't ask for the relative velocity. I don't care about the direction. I just want to, I care relative to each other, what would they see each other doing? If car 1 is going 40 kilometers per hour, car 2 is going 40 kilometers per hour, relative to each other, how fast are they going? 0. What about the second diagram, the one on the right? What's the relative speed? Don't worry about positive or negative. What's the relative speed? 20? Ooh. What's the relative speed for this one when they're coming towards each other? This is why head-on collisions are so much more damaging than getting rear-ended. Because getting rear-ended, there's a relative speed that's going to often cancel out. Ooh, they add together when you're going head-on. I just noticed I had a blank to write. For some reason, I wrote it up there and didn't notice that I put a spot there. Whatever. Okay. Let's do an application question with this. How will, first of all, I like these questions, these next few questions. How will you know this is a relative velocity question? Is there a graph? Is there more than one object? Are they moving at different speeds? Bada bing, bada boom. So, what's example 2 asking me to find? Time. I left a bunch of room down below, but I think we can fit it all in next to this diagram. You know, I have an equation that has time in it. It also has a d and a v. The v I'm going to use is the relative speed. I don't care about direction. What's the relative speed of these objects next to each other, compared to each other? Help me out. What's the relative speed? How'd you get the 8? You guys okay? I'm only getting the same answer from Connor. You guys picking this up, right? 13, 5, relative to each other, there's a difference of? 8. Okay. Oh, how far? Here's what I'm going to argue. For this train to pass the front train, its back corner has to make it all the way to there. That would be the definition of passing. That distance there. Oh, how big is that distance there? You know what, I could have made this question a little bit tougher. I could have actually included a distance between the trains as well, and you would have just added all 3 together. I think I did that in the homework, I think. 250, you say? I'm looking for an equation that has, well, this one, right? We're trying to get the t by itself. How would I get the t by itself? You don't say. It's going to be 250 divided by 8. Double check. Do my units all match? Is it meters, meters, seconds, seconds, and all good? Okay. What's the answer? Sorry? 31.25. I'll go 31.3 time seconds. I'd take 31.25. By the way, oh yeah, 3 sig figs. Look at all my numbers, right? 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. I wrote here, since both trains are moving, this seems like a difficult task. You know what? Both trains aren't moving, not relative to each other, Matt. One train is standing still and the other train is moving. That's how we'll handle this every time. A couple more. This was going to show how to do it, and I don't know. Anyways, I'm going to nuke that next year because I didn't realize we could fit it all quite nicely right there. Hey, let's go to an airport. Example 3. So as you hurry to catch your flight at the local airport, you encounter a moving walkway. Yay! That is 85 meters long and has a speed of 2.2 meters per second relative to the ground. Check. What's the speed of the walkway? 2.2. Check. If it takes you 68 seconds to cover the 85 meters when walking on the ground, how long will it take you to cover the same distance on the walkway? Assume you walk with the same speed on the walkway as you do on the ground. I am sensing here, is Adrian alive? Yeah? Okay. Adrian, I think you're on the ground, you're on the walkway. I think this question has 2 different situations. Ground and walkway. You agree with me? When there's 2 different situations, here's how I do that. And I'll even go like this. And I'll start deficting. I'll start listing my data. What do I know on the ground? You know what? That's 68 seconds. Is that on the walkway or is that on the ground? What is that? Ground. No, yeah, what is that though? 68 seconds. What is that? You know what? Right? This 85 meters, is this on the walkway or on the ground? I'm going to say D equals 85. Hey, what can I find? I can find a V. Which V? I think this is V while walking, which they didn't tell me. I'm looking for an equation. Oh, D equals VT. What do we want to get by itself this time? V, how would I get the V by itself? Divide what? Divide by? What's next to the V? Oh, so I want to move the T over. What's the T doing to the V? Adding, subtracting, multiplying, or dividing? So how will I move the T over? So you're saying divide by T. Are you saying, you are saying, that V equals D over T? Yeah. Oh, in fact, I see meters per second popping out of there too. The speed that you walk at on the ground is going to be 85 divided by 68, which is what? Oh, it works out nice? Oh, that's a fluke. So my walking speed is 1.25 meters per second, which also seems reasonable. That's about how fast I would be walking, I think. My steps are a little under a meter long. That's probably 2 steps every second. I'll go with that. Now, how fast is that on the walkway? On the walkway, did they tell me how far? Yeah, how far? Oh, also 85. Good. On the walkway, did they what do they want me to find on the walkway? Oh. So maybe there's that. Now, is there 2 objects moving now? Yeah, me and the walkway. I'm going to use the relative speed. What's the relative speed? I'm going in the same direction as the walkway. What's the walkway's speed? 2.2? What's my speed? So relative to the people on the ground, what's my relative speed? I think I can do this in my head. 3.7, no, 3.45? I want to find T. You know what? Didn't we find T like a question or 2 ago? Wasn't it this? Yeah? Or I could have said I have an I could have said I have an equation that's got a D, a V, and a T in it. How to get the T by itself? Divide by V. 85 divided by 3.45. You get 24.6? What if you went against the grain? What if you turned around and went against the walkway? What's B asking me to find? Ah! What's B asking me to find? Why? What tells you time? Okay. Hey, did they tell me how far? Now, are 2 things moving? Walkway and me? So I'm going to use the relative velocity. How fast is the walkway moving? 2.2. How fast am I walking in the opposite direction? According to this question now, 1.3. Did I say opposite direction? Opposite direction, we're going to go 2.2 take away 1.3, right? The same way as when the train guy was walking backwards, we subtracted. My relative velocity is going to be, is it 0.9? Yeah. So time is going to be distance divided by V. Hey. And again, I'm assuming most of you, if you haven't tried walking down an escalator against the grain or walking against a walkway. You've wanted to. We can at least do some of the physics ahead of time. How long will it take me? $94.4, is that right? Yeah? No, yes? Yeah? Units. Time. By the way, notice if you're walking, it would take you over a minute. The walkway saves almost 40 seconds. There's a reason why the airports pay for those walkways. If every pedestrian can save multiple seconds of time, that means they can get that many more planes out that much faster. That's money in the bank. I don't know if you ever wondered, like, why do they put these walkways in airports? We're certainly capable of walking on a horizontal floor. It's all faster. People get people out faster. It's an investment and a good one. Last one. I like example 4. I like example 4. I like example 4. Example 4 is the next question. I like it, first of all, because, hey, cops and robbers, cool. And, ooh, good physics. Police are in hot pursuit of a car, sirens, which is 320 meters ahead. And the car is going pretty fast. It's going 150 kilometers per hour. It's speeding. The police are going to ram the car. They want to ram it in 20 seconds. How fast do they need to go? So can you imagine? Bad guys, cop car, trying to catch up. What's this question asking me to find? Okay. Is there more than one object moving? Yeah. Are they moving at different speeds? Yeah. Actually, this question is asking me to find the relative velocity. We're going to pretend that the bad guys are standing still temporarily. And we're going to see how fast do the police need to go to catch up to them. Oh, what's that 320? What's that 150? Not going to use it. I'm going to pretend the bad guys are standing still. What else? Oh, what's that 20? Hey, the relative speed, do the units match? Meters, and seconds? Yes. Is going to be 320 divided by 20. What's the relative speed? 16? 16 what? Ooh. What did I give you the bad guy's speed in? Let's do a conversion. I know to go from meters per second to kilometers per hour, it's something to do with the 3.6. Do I times or do I divide? Times? So the relative velocity of the police car is going to be 16 times 3.6. It's going to be 57.6 kilometers per hour. That's how fast it needs to be going if the bad guys are standing still. Are the bad guys standing still? Oh, then you know what? It has to be going that much faster than the bad guys. Its relative speed relative to the bad guys needs to be 57 kilometers per hour. So what is the police? Has to be 150 plus 57.6. How fast are the cops going to have to be going? Without relative velocity, that's a very difficult question to solve. Okay? What's your homework? Well, you want to finish the take-home quiz for sure. I've attached some questions. Every one of these questions is fair game. Some of these are nasty. I didn't put the answers next to each question. Instead, they're scrambled at the bottom here. But I also note that I said I wanted to show you a couple of cool videos, so I'll do that first.